All right. The other day we were introduced to polar coordinates, and you found that there was a connection between polar coordinates and rectangular coordinates. So your rectangular coordinates, you know that x equals r cosine theta and y equals r sine theta. The r is your radius, so you can find your r by using the Pythagorean theorem, is what this is, which means that r would be the square root of x squared plus y squared. And you learn that theta can be found by taking the inverse tangent of y over x in most cases. Today we're going to learn about the connection between rectangular equations and polar equations. So we can have equations that are written in polar form, and then the next lesson we're actually going to graph equations that are in polar form. So for today, these top two equations are going to be important. We're actually going to need both of these. So solve for r with the square root and solve for r squared. This one will not really get used today. Okay, so the first thing we're going to do is we're going to look at changing rectangular equations into polar form. So pretty much, if you have an equation like this, so this is a linear equation, just replace the x and the y with what they equal. So x is r cosine theta, so r cosine theta, minus y is r sine theta, so r sine theta, equals 3. And then we want to have our equation solved for r. We want our final answer to be r equals. So for this one, the easiest thing to do would be to just factor out an r. And then divide both sides by the parentheses here, the cosine minus sine. So r will equal 3 over cosine theta minus sine theta, and then that is your answer. That's it. Okay? The one over here, this one's actually easier. Do not replace the x with r cosine and the y with r sine. For this one, just take a look at this entire expression, x squared plus y squared. Well, that is equal to r squared. So then, if I just take the square root of both sides, I will get r equals plus and minus 2, square root of 4. So really what we have two equations. We have r equals 2, or we have r equals negative 2. Now, if you look at the original equation, this is the equation of a circle. X squared plus y squared, that's a circle that has a radius of 2. Well, that's what these two equations are. And we'll learn more about these later, but if you were to graph these, both of these would be exactly the same. So it's the same equation, just kind of written twice. Okay? Now, the bottom part, we're going to go the other direction. So we're going to take polar equations. So this is what polar equations look like. We're going to take polar equations and translate them back into rectangular form. So the very first one, I've got r equals 4 sine theta. Well, having sine theta doesn't really help me. If you look up at the top, what I really want is to have something like this, r sine theta. Because if I had an r in front of the sine, then I could take that whole expression and replace it with y. So here's what we're going to do. We're going to take this one and we're going to do just that. We're going to give ourselves an r here by multiplying both sides by r. That'll turn this r into r squared. It'll turn this side into 4r sine theta. And now I can replace both sides. I can take the r squared, replace that with x squared plus y squared. I can take the r sine, replace it with a y. And now I have an equation that just has x's and y's. Now, this is a circle. Since we have an x squared and a y squared, if you remember back to last semester, that would be the equation of a circle. So what we're going to do is we're going to get this in standard form. This is something we've already done. It's been a few months, but you've already done this. All right, so let's get everything on the same side. So x squared plus y squared minus 4y. then we're going to leave a blank because we're going to complete the square on this, equals 0, and then we're going to leave a blank over here as well. Now, what's going to go in the blank? Half of this squared. So half of -4 is -2. -2 squared is 4, and so we're going to balance it out with a 4 over here. And now we have x squared plus, this is now a perfect square, y minus 2 squared equals, and then we have our 4. And that is our circle written back in rectangular form. Okay. The next one is, well, we don't know what it is yet. So let's take this. First thing we want to do is we have a fraction. We don't like fractions, so let's cross multiply. Now when we cross multiply, we have to distribute. That r is going to multiply both of these. So that's going to give us r cosine theta. It's also going to give us r sine theta equals 4. But r cosine is x, r sine is y. So that is the equation of a line. This is a line in, this is what's called standard form. You could also move the x to the other side and you would have negative x plus 4. That would be a line in like slope-intercept form. So if you needed to graph this, this would be in slope-intercept form. So this one may be the easier way to write it, but either way is actually fine with me. Okay, so that's a line. All right, we're saving the best for last. So, all right, this next one. So let's take a look at what this is. So again, let's cross multiply. Let's get rid of this fraction. So r times 1, that's going to be r. And then r times sine, that's going to be r sine theta equals 4. All right, so we need to replace these things. Well, r, again, if you look up at the box at the top, just plain r would be the square root of x squared plus y squared. And then plus, and then r sine is y equals 4. Now, I'd really like to get rid of that square root symbol. So what we're going to do is we're going to, eventually we want to square both sides of this. But right now is not a good time to do that. What I want to do is I want to get the y to the other side. So I want to get this radical by itself. So square root x squared plus y squared equals, and then I'm going to have 4 minus y. Now I want to square both sides. So that'll get rid of the radical. So I'll have x squared plus y squared equals, and then I'm going to have this side squared. Now remember, you need to FOIL this. It's not this squared and this squared. You need to FOIL this out. And if you need to go over to the side and maybe 4 minus y times 4 minus y to really see what that looks like, that's fine. Okay, but what you're going to get is 16, and then you're going to get minus 8y, and then the negative y times the negative y will give you plus y squared. Okay, now I've got a y squared over here and a y squared over here. Those are going to cancel each other out. So now I just have x squared equals 16 minus 8y. So now we should, if we remember back from last semester, we should have an idea of what this is. If you've got an equation that has an x squared and does not have a y squared, but only an x squared, then that is a parabola. So to get this in standard form, I'm just going to switch these two. So x squared equals negative 8y plus 16. I'm going to get the y by itself by factoring the negative 8 away from it. If I factor a negative 8 from a positive 16, I'm going to have a minus 2. So think about that. If I were to redistribute, the negative 8 times the negative 2 would give me a plus 16. And this is the standard form of a parabola. And that is it.